We're here at the European Conference for Computer Vision. We're going to talk to the Berkeley team responsible for Caffe, the GPU-accelerated machine learning framework.
Deep learning is a branch of machine learning that's been driving a lot of advances on perceptual problems, like vision and speech recognition. Deep models learn a rich representation of their input to do their task, so that if we were to recognize a cat, we can do it in terms of rich visual properties, like that a cat is furry and has a tail and is orange, instead of just trying to recognize it as a billion points of light, which is the raw input that a camera sees. To do this, deep models need to be presented with a massive amount of data and use a vast amount of computation, learning over millions of iterations, to improve the model bit by bit, so that with every image it sees of a cat, person, or car, it learns a slightly improved model. To explore and deploy these deep models, we created the Caffe framework, which lets you define these models with expressiveness so that we can try new tasks and try new variations, but also performance, so that we can learn these models on millions of images in our experiments and then deploy them in practice in an industry. To do this, we need to accelerate the computation, which we can do by parallelizing it on a GPU, so that in Caffe, we can actually recognize the contents of a single image in only 2.5 milliseconds, which allows us to process over 40 million images a day on a single device with Caffe at massive, even internet scales. With the new CuDNN library developed by NVIDIA, it's further accelerated the key routines of deep models, so that now we can actually infer the contents of an image in just over a millisecond. These models can learn to do all sorts of visual tasks, even recognize the style of a photo or painting, so that it could see an image and know that it's a vintage photo or a romantic scene, or that a painting was done in the Impressionist style. And even we can relate images together by their similarities in style, so that I could ask of all the photos I've taken, which is the most Impressionist, or which is the most geometric, or given a certain photo I've taken, ask, what style of painting most suits the mood of this set of photos in my collection. With new data and tasks emerging daily, it's important to be able to experiment and deploy new models all the time. And Caffe and CuDNN give you the performance and expressiveness to create and learn these new models quickly.